Приветствую всех присоединившихся к нашему стриму.
Hi, everybody. We are going to talk about the development of AI scientifically.
Здравствуйте. Меня зовут Игорь.
Good morning, my name is Igor Kuralenok. I joined Ozon this autumn and I'm in charge of the search and catalog. But my role today is different. We are going to talk about LLMs, large linguistic models. I'm going to represent and introduce what LLM and why they should be so large. Because language models are statistical models by way of sequences can regenerate or recover the end of the phrase by the beginning of the phrase or by the whole phrase to recover the middle of it. Why is it so important for us, such models? Because they're capable of analyzing the internal dependencies inside those sequences. And it means that they're capable of align the words and track the internal logic of the whole phrase, and also they're capable of taking into account root cause. That is why the language models are a very powerful instrument capable of self-training on big text corpuses. Conditionally speaking, if there's a text, Tolstoy, War and Peace, and a language model can extract some knowledge from it. Recently, this field has obtained an impetus with the appearance of neural networks distribution and expansion. That was expressed in recurrent models first and then transformer models. Vivid example of those transformer models are, famous ChatGPT and BERT. ChatGPT opened up an opportunity to communicate with language model using just a simple dialogue interface. Any user of the system can talk to the model in the language he wants. And the people realize what they can do and solving such interesting tasks using the models. Interesting feature of such models is that they actually not only working for the text, they can process programming language, helping us programming very difficult things. But not only this, they can look at the consequences and the sequences of programs and recognize the voice or look at the sequences of sensors indicators to predict what will happen next. So thus, LLMs have overstepped beyond their industry and domain. Linguistics was the input and can be applied to a very wide range of tasks. Why are they so large? Because the bigger the language, the more subtle dependencies it can fish. So the growing of models, and we can see that they're growing everywhere. They can do more and more and extract the sense and essence of what we put into it. So let's get down to our session today. We are going to have a number of interesting reports and presentations about the practical use of such models, and we'll start with Ayush Mudgal, senior engineer of Pinterest. He is going to talk about the evolution of the rating of ads. Grigory Alexeyenko, Bear Devices chief engineer, going to talk about transformer models to identify age and gender. Igor Gorbelov, Just AI, going to talk about the architecture of platform of the models. Elizaveta Gorchurova, candidate of physical and mathematical sciences, scientific expert of AI and Higher School of Economics, going to talk about Fusion Brain platform, using which you can generate images. And I am going now to talk you in more details as to how large language models can be used in search. So the biggest part of my life I've been doing search. That is why in this section it would be bizarre if I would be talking about something else but to how to use LLM in search. Well, but the first question that we should ask is why we should do it in the first place. And for this we should recollect as to what search is. Search has always been based on the recent achievements of language understanding. And the language models made a revolution in the field. That is why it would be strange if we would not try in search to use those LLMs. Besides, large models, as I said, they have a lot of important features. One is that we can use those models for working practically with any language, and thus we can build up language-agnostic models on the one hand, but on the other we can add different modalities to build up a single search both for the text and images and video and so on. However, we have a lot of ways as to how we can integrate LLMs into search. And I would like to split those ways into four different approaches. The first approach that comes to my mind is to use so-called vector search by documents, or to use its hybrid vector search, combining text and vector. So another one is to use the same vector search, but not by accuracy of one document, but by token positions. Well, of course, there are complications here with storage. That is why the dense version is used as well as the sparse version. Besides, there's a special sparse version of the models, as far as I think, is the early interaction model, or the query indices model, and I hope to talk about that too. And finally, the last one, I would talk about dialogue search. Recently, a lot of talks about that we can hear. But we will start with the most natural approach, which comes to my mind first. And actually, the majority of people did try it. For instance, a long time ago, we tried to set such a system with first embeddings, global and word-to-word, and seemingly it's a very simple approach, and we can build up document embeddings to aggregate the positional embeddings in a way. Then what we can do is to use standard product by neighbors. Out of two standard components, we will get the search. Great. But this search will not be just to search by words as a traditional one, but by senses. Actually, however, unfortunately, practically it turned out to be not very effective because such system makes a lot of logical mistakes. The red and blue dresses, but they are very similar from the point of view of this model. But from the point of the person who looks at the results, sees those outstanding mistakes. That is why vector approach is used very rarely in one. Well, we use the hybrid model. Usually we take the vector model, which can provide the semantic search for us, to complement it with the classical search, and thus we would improve the results in so-called long tail. For those queries, we have nothing good to offer, I mean, traditionally, and we are trying to sort of enrich them with a vector search. This approach is the basis for a big number of industrial systems, and in my perspective is more or less state-of-the-art in the field. However, this approach, of course, has a lot of drawbacks, specifically specifically, as you can see, we are using the vector for all the documents, and the document can be quite lengthy. It can have different parts devoted to different aspects or, for instance, different topics. And when we combine them in one vector, sometimes it happens there's something, well, it can come up to nonsense. So that is why it's an industrial state of the art, of course, but there exists some research in the field of information retrieval, which provides other approaches. Specifically very important, on the one hand, theoretical achievement, but on the other is academic achievement, but also practical system, which also can be tried. It's position embedding. In this case, the basis of those neighboring candidates, we put not the vectors for the whole document, but the vectors of each of the position. And using those vectors, we are searching the closest neighbors of the vectors of queries or tokens of requests. And then using the results, we can select the neighboring documents. And this approach provides very good results alone, without the text search. Well, better, of course, with text search, but even alone, it does quite well. But it's not the most recent dense retrieval models. Well, there are other models that can provide better efficiency, but nevertheless, that's quite a substantial approach, which is implementable, which is doable. And however, if we have quite a big database, which requires a lot of storage space, as I said, every position in the document, I mean, for each, conditionally speaking, a word or sub-word even, we have to store the embedding, which is quite a big thing. Usually it's a vector, about 700 doubles, and you have to store it somehow save it. For industrial search systems, for a word, you usually have one long. It's 8 bytes. And here we spend even more, much more, 100 times more, which is too big. And if we have quite a big database we would like to search from, well, we will not be able to do it. Two approaches here to offer to solve the issue. The first one in the framework of any search of the proximity neighbors, we have mechanisms of compressing, and we can provide it in a smaller way. For instance, instead of 32 bytes, we can use 8 bytes. But in this way, very often, while the zest is lost, and we might have some mistakes that will spoil the whole of the sense of it. Interestingly, the calculator, in some way, the children's powder was the neighboring word. So that is why another approach, which is more practical in my perspective, is sparsification of those vectors, where we can say that here is the dense space. We would transform it into compressed or sparse space. And for this, we have quite a big number of research done, specifically related to how optimize in the right way the space. And as I said, what happens there is that we are trying to optimize the representing of documents in sparse space. What does it mean? It means that our document or the word or position will have a small number of hypotheses in this space of representation. But every hypothesis then will be able to store classically converted list. And we will say that for this hypothesis number 186, we will have the documents number 344, 4, 4, 5, 8, and so on and so forth. And at the moment of search, on the one hand, it's quite a compact storage structure because the vectors are sparse. But on the other hand, at the moment of search, we will be able to use the standard primitives of search. I mean, when we take the list of documents that are corresponding to this or that aspects, we can just merge them to find the candidates which would correspond to all the hypotheses of the request. This concept at the moment is quite well surveyed, and there are a number of works done in this field. And personally, I like this approach. The only thing is that I like working with untitled hypotheses, and it would be great for me to have for each hypothesis to have some sense underpinning. And usually it is reflected in words. So my favorite here is the approach when we are using the special title or name for our hypothesis space. Conditionally speaking, the list of documents are stored, for instance, which correspond to all the courses in drawing. All drawing courses and documents about those documents are put into a separate list. And if I'm interested in online drawing lessons, then I can take the list to match it against all other lists of documents online, which is related to online. That's my sparse introduction of big vectors can be put in a very clear-cut hypothesis space, which then will traditional for the search, but on the other will allow us to apply quite big models, because for those pieces I mentioned of titles, of names, I can use well, to look at the combination of this piece and matching the document, I can use a big model because I use it offline and not online. And why this mechanism is going to be easy? On the one hand, I'm using the heavy model offline and very easy one in online, not to reload the system, overload the system. And if I look at the hypothesis space, not just a space of hypothesis, but some image or part of elements of queries or requests, then in the framework of the structure, I can index not only the text documents to a large extent. I can, for instance, find any videos that can match this or that queries. For instance, I have a query as for instance, lectures on LLMs, for instance. Great. I can take all those videos in the list and put them in there.
So once I receive a query which contains the large language models, I simply need to follow that list. In this way, the early interaction model or the query index model may be used in building multimodal, which combine the capacities of the large language models in terms of delivering the results and presenting them. On the other hand, allow one to work in the language agnostic and multimodal environment. And my story wouldn't be complete if I don't tell you about the dialogue systems and the dialogue model. Seemingly, quite recently, a ChatGPT appeared. Everybody had a chance to interact with it and found out that it can tell us a lot of interesting materials from internet. If we talk about the Risen model, that will be even more than that. However, this kind of an approach has a few drawbacks. First of all, we have a problem with the model itself. This model reflects a certain template upon which it was trained, so to update it is a bit complex. And if we are interested in doing a search for some sort of a news or something that is vital currently, these kind of queries will be the things that the model won't be able to do. The second problem is that it makes mistakes, and these mistakes are very subtle, whereas in the past, the very same recognition models, which are currently following the same similar principles, were making obvious errors. For example, Cayenne Porsche instead of Porsche Cayenne, and everybody would understand that that is a mistake. The mistakes currently are more subtle. The young man of 26 years instead of 32, and I wouldn't go for the information from a big generative models trying to calculate a certain medicine dose. So if we generate the content in full, it makes our internet poor. So it's not beneficial to create a new content because the whole of the new content can be generated and consumed by the net and then regenerated in the process of a dialogue with the user, and then the authorship will be with the GPT rather than any specific individual. And that is quite a big issue in terms of the economic model of content generation. And overall, ChatGPT is taking a certain accountability. And many have noticed that generative models quite often are trying to avoid complex questions. But the problem is that not only we experience difficulties with the model, we also have difficulties with the user, because most of the users in search, these are the users with mobile gadgets. And I feel that the biggest problem with the mobile gadgets is rather not consuming an answer, but formulating a query, because it is difficult to print with one finger. Then speaking out in the street is not always a pleasant thing, and we avoid it because of different considerations. And so what happens is that we've got a very narrow interaction channel between ourselves and the gadget, and constantly between ourselves and the model. And so, generally speaking, I think that many caught themselves thinking that even for a smart person, it is difficult to word a query in the correct way, because such a query would contain half of an answer. And that makes it the problem of the dialogue system, a fundamental one. So it's the model on the one hand, on the other, just to explain what is it that we want can at times be very difficult. So I believe that it is a dialogue search in the form and shape that we currently envision is not the most effective application of the LLM, including the generative models, in our search. And so I think that this is the journey that we would be following in a slightly different format, because a language model may have two important roles to play. The first one is that we are establishing a certain system which squeezes information from a user. If you may recall, in iSearch we have a search prompt. We have different ways of saying that I currently need text, tomorrow I will need videos, and so on. And it is exactly the dialogue, not in words and terminology, but in certain activities. Push this button, click this button. So you start putting in a query, and I suggest to you the way the next part should be added to it. That is a certain push activity, and this is a certain proposition that the large language model can offer to us. And so building this kind of a dialogue, I believe, is the immediate future of the search system. Now, the second way of applying LLMs is their capacity to aggregate the result. For the language model, a search may not be an adversary, but an assistant. So a language model enters into the search interface and communicates with the search using its native API and translates what the user wants into the language of the search system, in which case a search system generates certain responses like images or video or text, and subsequently our model aggregates all of these results into a certain single response. And here we're able to solve quite a few of the problems that I mentioned above. Updating, because our database is being updated quite all right. Secondly, we get references to the documentation which was in the basis of it, and so we resolve the problem of authenticity this way. So this particular approach, I believe, is going to start being applied in the immediate future by a big number of different industrial search systems, and I'm hopeful that we will all be witnessing it and enjoying it.